Hey guys, welcome back to the channel. So the last time I remember we have done this problem here rotating the box and seems wait a minute. It seems like the starred ones are important. Uh, it's not mentioned. I see four because that gives an minds up that gives hint and what the typical example problem is star. Okay, so the star ones are the typical example problem. Uh, One I could say is the two sum problem. So let's see. Let's go to the next problem. So this problem is a medium uh, range problem and lead code 189 189 rotate array. So the problem statement goes like this. We are given an array named nums and rotate the array to the right. Okay, by k steps. Okay, we have to rotate the array to the right where k is non-negative. Okay, we were given nums right by k steps. Okay. So I have to rotate the array by 3 times and why did I feel like I have done it already but seems like we didn't. I mean I didn't. So what are we gonna do? Here k equals to 3 and so we have to rotate like 1 should go back, sorry 7 should come front to the right. So 7 should be coming to the front and 6 to the front again and 5 to the front which is k times. So that's it. So what are we gonna do it? We'll pop the array. Okay, let's see the constraints. So k will be between 0 and 10 to the power of 5. K is 0, then we have to return the array as it is, and the numbers will be between minus 2 to the power of 31 and 2 to the power of 31 minus 1, and length will be between 1 and 10 to the power of 5. Try to come up with as many solutions as you can. There are at least 3 different ways to solve this problem. Okay, could you do it in place with order of one extra space? Okay, he's asking to do in place traversal. I mean not traversal, in place uh, juggling the numbers without creating a new array. Yes, we can do it, but inserting will take order of n time, which is very huge. What can we do? Let's think about it. So say into the front. So k will be, what if k is greater than the length of array? So let's do one thing. If k is, first handle the edge case. If k is 0, then we shall return the nums as it is. Inserting to the front is very computationally expensive. So we can do one thing, I guess. Now let's normalize the k. So the normalized value will be k percent length of comes. If k is 7 in this case, k percent 7 will be 0 because 2, 3, 4, 5, 6, 7. Right. We have normalized the k, so we have to iterate normalize the times. And what are we gonna do? Extend. So we're taking the last value. Zero one. Now norm is norms of norm minus height minus 1 is to value, and finally we're gonna return nonce. Let's see if it works, and if it works, let's submit and let me explain the intuition. 5, 6, 7. Yes, it seems like it didn't depend, I mean extended. So let's see a Python compiler and One, two, three, four. Okay. Seems like we need extra space here. Okay. Our goal is to. Um, this is not gonna work. What do we do? If we insert it at the starting, then it will take order of an operations. I mean, right? It will take order of an operations to move each element to the right side. So inserting at the starting is not the ideal option. Seems like we have to compromise for at least one thing. Oh, So we have did this, but it is not the optimal way. I mean, in terms of time complexity, it's not the optimal way. Let's try submitting it and see. It took 1028 milliseconds, but the space complexity is very optimal. We can do, but we need to have extra space here. So, uh, now let's see another approach. Now let's see. Sorry, guys, sorry. Let's print. Now let's see. Okay, so we are popping nums. Okay, okay, I got it, guys. So in place edit is we cannot, we have to preserve the nums. Understood, guys. So in place here we are doing in place only, but it is not optimal as I said. To make it optimal, so since we have submitted it, let's discuss the inclusion first. So what we are doing here, we are taking the edge, like we are managing the edge guess. If k is equals to 0, I mean if k is 0, then we are returning the nums as it is, and if it is not, k might be greater than the length of nums. So what we are doing, we are taking a normalized value that will lies within the range of length of nums. Sorry guys, let's do another thing. Let's keep norm here instead, and oh, this will be way better. 128. Let's see the better one. So we are normalizing the value between 0 and the length of nums. So k lies within the 0 and nums of 1. You can understand if you are familiar with the modulo operation in mathematics. So if the norm is same as norm is 0, then k is divisible by the length of numbers, and if it is divisible by the length of numbers, then that means we don't need to uh, juggle any values. We can directly return the number as it is, and if we get any number other than 0, then we are popping numbers from the back norm times the value times, and we are inserting at the zeros position, which will take order of n. So our time complexity here is order of n into order, order of n into k. So let's see if it can be optimized by asking, not asking, let's check another other solutions here. Oh, okay, go to paper someone. Wait a minute. If we slice until, so here we are slicing from the last case, if it is 3, I think also minus 3. So it is slicing the last k elements. and adding those to the front. And the first k, leaving the k elements, the remaining first elements are added to the right side. I don't know how much time it will take for slicing. Complexity for list slicing. That here it is the length of the resulting slice. If that is true, then it will be order of n time complexity. Let's try doing this. So what he's doing is so slicing the last and adding it to the sorry. Oh, seems like we don't need to return. Okay, let's try submitting it again and see how much time it will take. If it is less than 1000, then it's good. Right. It is showing 0 milliseconds, which is completely bullshit, completely uh, unacceptable. Let's also ask space complexity, where k is the length of the resulting slide. This is because creating a slice involves copying the elements within the specified range into a new list. Okay, and k is okay, guys. So it violates one thing. It violates the space complexity thing because slicing a string will, I mean, slicing a string or array will give a new array of length k and remind n minus k here. So the space complexity is maximum of k and n minus k. And here what we are doing is we are uh, we are what do we call it? Sorry guys, I just forgot. Let me take a second and I will explain. Mm, yeah, yeah, I just remembered. So we are changing the pointer to this new array. So it will give a new array and nums the pointer that points to nums is now pointing to this new array, then we are creating this new array which will be at the address of nums, and nums address will be lost or deleted. So I hope you guys understand, and let's meet again with a new video. Keep pushing hard and work hard, guys. Bye. Take care. Thank you for being here.